In a universe ruled by an unshakable law, one voice, one single voice, dared to ask a question that would shake the very foundations of reality. This isn't just a story about physics. This is the story of a cosmic rebellion. This is Mach's Principle.
Okay, let's just jump right in. I want you to think about a force you can't see, but you can absolutely 100% feel. It's a power that governs your every single moment. But here's the real question. Is that force coming from inside you, or is it coming from somewhere else entirely?
You know what I'm talking about, right? You're on a merry-go-round, it's spinning faster and faster, and this invisible hand just seems to be pulling you outwards. You have to grip on for dear life just to stay put.
Or what about this one? The light turns green, the car takes off, and bam! You're slammed back into your seat, like some invisible weight has just been dropped on you. So where's this mysterious power even come from? Well, science has a name for this power. It's called inertia. But don't let the boring textbook name fool you. This isn't just some abstract concept. It's a fundamental force of nature that you are literally battling every single day.
For centuries, one name, just one, ruled our entire understanding of this force. He didn't just write the rules. He built the very arena where all of reality played out. His name was Isaac Newton.
And Newton's word was law. He declared that everything happens on this vast, invisible, and totally unchanging stage he called absolute space. Just picture it like a cosmic grid, fixed, eternal, unmoving.
So in Newton's world, it was simple. If you were moving against this fixed backdrop. Your speed wasn't relative to the car next to you. No, it was relative to space itself. It was clean, it was powerful, and for over 200 years it was undisputed law. But then a challenger appears, a physicist and philosopher named Ernst Mach. And he looks at the same universe, but he sees something completely different. He doesn't see a fixed stage. He sees a cosmic dance. And this is where the epic clash of ideas really happens. See, Newton said your inertia, that resistance to change, it's just something you're born with. It's an internal, intrinsic property. But Mach proposed something way more radical. He said your inertia isn't a property, it's a relationship. It's a living connection to every star, every galaxy, every single speck of dust in the entire universe.
Think about how crazy that sounds. The mass over there influences inertia over here. What Mach is saying is that those far-flung galaxies aren't just pretty lights in the sky. They are actively defining your reality right here, right now. They are the source of that force you feel.
Now, to really get this battle, we need to understand the fighter's special abilities. We're talking about two powers that seem similar, but are actually fundamentally different: mass and inertia.
Okay, so think of mass as like your character's base stat in a video game. It's the amount of stuff you're actually made of. It's your fundamental potential, your inner source code. And it doesn't change whether you're on Earth, the moon, or floating in deep space.
Inertia, on the other hand, is the active expression of that mass. It's your shield. It's the force field that keeps you moving in a straight line, or just keeps you chilling at rest. It's your active resistance to any outside force trying to mess with your path.
And the rule is super simple. The more mass you've got, the more powerful your inertial shield becomes. That means it's harder to get you moving, and it's a whole lot harder to stop you once you are.
So this philosophical war, it needed a battlefield. And funny enough, Newton had already designed the perfect one almost 200 years earlier. It was a thought experiment that we now call the bucket duel. All right, here's how it goes. First, everything's still. Water's totally flat. Then you start spinning only the bucket. The water inside hasn't caught up yet, so it stays flat. But pretty soon, friction gets the water spinning too, and its surface curves inward, right? Finally, you stop the bucket cold, but the water, thanks to its inertia, keeps on spinning, its surface still curved.
And this leads us to the ultimate question. In those moments when the water is curved, it's clearly feeling a force. But what is it spinning relative to? How does the water know that it's supposed to curve?
Newton's answer was basically a knockout blow. He said, simple, the water isn't spinning relative to the bucket, it's spinning relative to absolute space itself. The cosmic stage is what's telling the water what to do. Mic drop, case closed. But 2 centuries later, Mach delivers this stunning counterpunch. He asks, okay, fine, but imagine a universe with nothing in it, and I mean nothing, just that one single bucket of water. Now, if you spun it, with the surface curve. Without the sun, the moon, the distant stars to act as a reference, how could you even define what spinning is? Suddenly, the whole idea becomes meaningless.
Now, Mach didn't exactly defeat Newton, but his rebellion, it lit a fire. He didn't have all the answers, not by a long shot, but he was asking all the right questions. And as it turns out, one young patent clerk was listening very, very closely.
And you can just see the lineage right here. Newton sets the stage. Mach comes along and challenges the very foundation of that stage. And then, a young Albert Einstein, totally inspired by Mach's rebellion, comes in and just tears the whole stage down and rebuilds the entire universe from scratch.
Mach's principle literally became a guiding light for Einstein. This idea that mass and energy don't just exist in space, but that they actually tell space how to curve and bend. The distant stars don't just give us a reference point. They are weaving the very fabric of reality that you and I live in every day.
So, we end with this, a question that comes directly from Mach's rebellion. If your inertia, your shield, really is a connection to the entire cosmos, what would happen if that cosmos just disappeared? Poof, gone. Would the slightest touch send you flying off at unimaginable speed? Would you, in that one moment, become truly and utterly weightless? The wild part is, we're still figuring that one out.
The battle for the soul of the universe continues.